Hello, hello, calculus students. How are you? I hope everybody's doing well. Today we're going to be talking about Euler's method. Euler's method is a way of approximating a function value using the slope at infinitely many closer points. Okay, you've already approximated function values before when we've been using our tangent line approximation. What Euler's method allows us to do is to get a little closer in those approximations by taking multiple steps. If you look at this image here from our textbook, okay, it is on page 325 if you want to actually open your textbook and peek at it. But what this tells us is they have that blue curve right here, okay? And that blue curve shows us also a point xy. And then we have our red tangent line extending from that coordinate point xy. So what we have here is we have a small change in x, okay? That's like our step size, what we're approximating in between, the steps we're going to take. We are then going to use our change in y, our delta y. Delta y is dy dx times delta x, okay? That's something you're going to need to remember. And then with those points and those changes, we will create a new point, okay? X plus delta x, y plus delta y. And the idea is you can keep going with all of these changes in y's and change in x's to build the curve and to create a good function approximation. So let's get into an example and see what this would look like in actually solving one. Okay, dy dx is going to be x plus y. We're giving you that f of 2 equals 0, and we want to use Euler's method with delta x being 0.2, and we want to approximate 2.6. The easiest way to tackle Euler's method is to go ahead and make a table. So we're going to say we got x, we got y, we are going to have our delta y, and if you remember from that image, that is dy dx times delta x, and that's super important. And then that will give us our next y. Can I spell next properly? Okay. Our next y by finding y and adding delta y to it. That's going to give us our next y value. All right, so let's rock and roll with this one and give it a shot. This is the setup here. Okay, as we go through this problem, if you have any questions, jot them down, email them to your teacher, okay? Or you can just bring them up next time we see each other. Here we go. They tell us that we are going to start with 2, 0. That's the coordinate point they give us, okay? They tell us that we need to get to 2.6. So I'm going to write 2.6 down here. I always like to fill in my x values first to kind of see how many steps I'm going to take. And if I have to go in increments from 2 to 2.6 by 0.2, that would mean I'd have 2.2 and 2.4. So that's what that delta x is over here. So it tells us the change in x for each of our steps. Okay? We have to go through the process to find our y values. So step 1, what we're going to do is we are going to take our 2, 0 x value and y value right here, and we're going to plug it into dy dx. 2 plus 0. Then we have to multiply by our delta x, 0.2. That's going to give us our delta y, which is 0.4. Then we take our delta y, we are going to add it to our original y value, and we are going to get our next y, and that'll come right down here to 0.4. And we're going to keep repeating these same steps. So I'm going to take, again, x plus y, but it's a new x and a new y value. Okay, so I have 2.2 plus 0.4. We're still going to multiply by delta x. That part never changes, so don't forget it. That'll give us a new decimal of 0.52. And if you don't already have your calculator, you're gonna want one because we're dealing with a ton of decimals today. All right, so we're gonna take that 0.52. we are going to add it with our 0.4 to create a new y value of 0.92. Bring that down here into our next table of 0.92. And we are going to go one more time. So we're going to say, okay, I have 2.4. I'm going to add 0.92 to that. Multiply all of that by 0.2. And that's going to give me, tippity type away on your calculator, 0.664. I ran over my line, I'm sorry. Then we're going to take 0.664, add it with 0.92. That's supposed to be an adding, okay? And we would get 1.584. And that is our approximation for 2.6, 1.584. You could write it down here, or you could also say f of 2.6 is approximately 1.584. Right there. Okay? Both of those ways of writing are totally acceptable, but the table is our setup and the process of all this. So hopefully, okay, we kind of see it. It's not challenging. It's sort of mechanical and just following the steps in the process, and you do the steps multiple times. Let's go ahead and peek at another one. Question 2. All right, I'm giving you that dy dx is 2 minus x. I'm telling you the coordinate point 2, 3 is on y, and I'm asking you to approximate y of 1.5 in 5 equal steps. Noticing here, I didn't tell you what delta x was. So you need to now think and tell me, what is delta x? And you're probably thinking, well, if I'm going down from 2 to 1.5 in 5 steps, delta x would have to be, yep, I know, I heard it. Very good. Delta x would have to be negative 0.1. Wow, I skipped to the next thing. Sorry about that. Okay, so delta x would be negative 0.1. So as we make our table, because we got to make our table every time, delta y giving me lots of room there for delta y and our next y. If you need to write down each time how to find delta y and the next y, you can. Remember that delta y is dy dx times delta x times delta x. And your next y is going to be y plus delta y. If you want to write that down, you can. You don't have to. Okay, as you get to do more practice with these, it's just going to sort of become like second nature. All right, now if I'm going down from 2 to 1.5, I'm going to have 1.9, 1.8, 1.7, 1.6, and 1.5, okay? If you want to, you can certainly pause the video, try this one on your own and see how you do, but we do have one more problem after this, so just 3 problems to practice our Euler's method for today. Right? In the first step, I always like to just write out so you guys can see where we're getting these values from. 2x minus y, plugging in the values here, and then times, come on, my stylus is like stopping working, negative 0.1. That's going to give us negative 0.1 when we simplify that, negative 0.1. There we go. And then we're going to take 3 plus our negative 0.1. And yeah, you can totally write that as 3 minus, but we're going to get 2.9. Bring it on down here. 2.9. Okay? And we repeat. Okay? 1.9 times 2 minus 2.9 would give us 0.9. Again, multiplying that by 0.1 will give us negative 0.09. Careful with multiplying your decimals. Use your calculator if you need to. And when we subtract 0.09 from 2.9, we get 2.81. And we're going to go again. 2.81. Okay, same thing, plugging in, and at this point, okay, you've shown your work for that first step. If you just want to jump to straight typing it in on your calculator and going straight to negative 0.079, that's totally fine, okay? And then showing this work here, okay? I highly recommend showing your work for like the first 2 steps, and then at that point, you can just jump to the calculator because the decimals get so much longer, it doesn't always fit in the space in the table that we've created here. Now, the nice thing that you want to remember, 2.731, I got carried away there, is you're going to get to a point where you're going to have more than 3 decimals, and that's totally okay. We're not going to cut off our approximation because we've always been told to stop at 3 decimals. We're going to keep going because we want the most accurate approximation we have. So when you're doing these Euler method problems, keep going. Don't cut it off because it's past 3 decimals. We want it to be that accurate, especially since it's just an approximation. All right, so there we are. Final answer, 1.5, we say is 2.1051. Put a little box around that guy. And again, it's just sort of mechanical steps that you're just working through. It's nothing overly challenging. Sometimes when you have problems that have 5 steps, you're like, oh my gosh, really? 5 steps? Is that necessary? But there we go. One more. dy dx is x minus y. I'm telling you f of 1 equals 2, and I want you to approximate f of 2 if delta x is 0.25. So now my question to you is, how many steps do you have here? You're right, we're going to do 4 steps. Very good. Okay, so let's make our table. And this one is going to be our you-do problem. So I highly recommend that you pause the video and that you come back and check your work when you are done. All right. So, welcome back. Let's check our answers. Here we go. We are going to have f of 1 and 2. Again, I like to show my steps here for the first one. So I'm going to say 1 minus 2 times 0.25. Decimals don't like, my stylus doesn't like writing decimals on this guy. And that's going to give me negative 0.25, negative 0.25, and that would make 2 minus 0.25. So I would get 1.75 here. All right, so we got 1.75. All right, that's going to carry on down here. My next step would be 1.25, 1.75. And if you want to, again, I normally like to fill in all of my x's to get all the way to show how many steps. You don't have to. You can go step by step as you go along. It's whatever works for you. All right, so again, I have 1.25 minusing 1.75 times 0.25 gives me goodness, I got carried away with my decimals. Negative 0.125, which would give me 1.625 over here. And we're going to bring that guy down here, 1.625. Again, same idea. X, which is 1.5, minus y, which is 1.625, times 0.25 is negative 0.03125. Adding the y and the delta y together, I get 1.59375. And we got one more step. Here we go. Oh, I don't know if I can fit this. 3, 7, yikes, we did it. All right. Okay, so again, x minus y times 0.25. I have, it's positive. Okay, positive 0.0390625. That is way past 3 decimal places. 1.6328125. Goodness. For our final answer, and actually I'm going to erase this guy and write this at the bottom by saying f of 2 is approximately 1.6328125. Pretty little box. There we go. All right, so hopefully you're feeling pretty comfortable with Euler's method. It's just a nice table, some steps to follow. Remember, what we're doing is we're taking a curve, okay? And we're taking the slope of that curve at really, really tiny steps, okay? To build and approximate the next step. So it's pretty awesome when you think about exactly what you're doing. But I hope you guys enjoyed the video. I hope you have a wonderful day. You're going to have some problems posted online for you to do to practice Euler's method. Any questions, make sure you bring them up the next time we see each other. And go and have a great day. Bye, guys.